Welcome to the first lesson in Session 7 on the properties of circles. A circle is a two-dimensional shape made by drawing a curve that is always the same distance around a center, which we identify as point C. A circle contains 360 degrees. A chord is a line segment that connects 2 points on a circle. For example, AB is a chord of circle C. A diameter is a special type of chord that passes through the center of a circle. So in circle C, line segment DE represents a diameter. So the diameter is a chord that passes through the center of the circle. The radius is the distance from the center to an edge of the circle. So for circle C, line segment CA represents the radius. The radius is equal to half of a circle's diameter. The measurements of a circle are as follows. So we're going to cover the circumference and the area. The circumference represents the distance around a circle. Pi is the ratio of a circle's circumference to its diameter. So regardless of the size of a circle, if you take the circumference of a circle and divide it by its diameter, you get the irrational constant, pi. It's often abbreviated as 3.14. The circumference of a circle is given as 2 pi r, 2 times pi times the radius. The area of a circle is the number of square units inside the circle. And the area of a circle is given as pi times the radius squared. The arc of a circle is the section of the circumference of a circle. So the arc of a circle can be measured in two ways. It can be measured in degrees or it can be measured in length, but it's a piece of the circumference. Here we have a central angle, is an angle with endpoints on the edge of a circle and an apex at the center of the circle. So for circle C, angle ACB is considered to be a central angle because its endpoints, which are A and B, lie on the circle, and its apex, C, is the center of the circle. The degree measure of an arc is equal to the measure of the central angle that intercepts the arc. So in this case, the measure of arc AB is equal to the measure of angle ACB. So in this case, we'll go ahead and identify them as x degrees. The length of an arc is the portion of its circumference. So we can measure it in degrees with respect to the central angle, or we can measure the length of an arc with respect to the circumference. So if we want to calculate the arc length, we would take the degree of the arc divided by 360 degrees multiplied by the circumference. So it's a fraction of the circumference. An inscribed angle is an angle formed by two chords in a circle that have a common endpoint. So in this circle, angle ADB represents an inscribed angle because it's formed by two chords, the chords being AD and BD, and they have a common endpoint, which is point D. So angle ADB is an inscribed angle. And the measure of an inscribed angle is equal to half of the arc that it creates. So if arc AB is x degrees, then angle ADB is going to be half of that, so 1/2 x. Next, we're going to learn about a couple of lines. First, we have a tangent line. A tangent line is a line that intersects a circle at a single point. The point where the tangent line touches the circle is called the point of tangency. Here we have point A is the point of tangency for the line that touches circle C. The tangent line intersects the radius of the circle at a 90-degree angle. So if we were to connect a radius from the center of circle C to the point of tangent C at A, what will be produced is a right angle between the radius and the tangent line. Next, we have a secant line. A secant is a line that intersects the circle in 2 points. In this case, line BD represents a secant. It intersects the circle in 2 points. And that wraps up our first lesson in session 7. Good luck on the quiz, and email us if you have any questions.